Alright, ladies and gentlemen, this is our fifth presentation, and this week we start talking about the structure of matter. So previous weeks we talked about describing matter, and then we talked about what happens when matter changes last week, and then now we're going to talk about what does matter actually look like when we break it down. If we had a very small, powerful microscope, and there's none that exists to this point, but if we did, what would that structure look like? And the thing that we're going to talk about is the atom, right? You probably heard this word before, or this thing. Might not know a little bit about it, but this is basically the idea of how the atom functions is what chemistry is all about. Okay, so let's get started. All right, first thing is this, the structure of matter. And we've already talked about this, that all matter is made up of atoms. All right, so let's highlight that. All right, as we're going through, now there's different types of atoms, and we'll talk a little bit more about that. It's basically similar to the fact that when we talked about last week or 2 weeks ago about elements, well, atoms make up elements. All right, so we'll talk a little bit more about how do we know what each atom looks like. But the bottom line is this, the matter is the basic building block of matter. So the atom is, all right? So if you want to think of the atom as a Lego, right? One piece of Lego really doesn't make anything, but when you start putting together those Legos together, you start creating something. You can make a helicopter out of Legos. You can make a castle out of it. And that's exactly what an atom does, all right? You have, in your body, you have, I can't even describe the number. It's trillions upon trillions upon trillions of these little tiny things that make up your body. And what they do is they build on top of each other like a Lego does to create what you see. All right, and that's basically the idea of it. And what we're going to talk about this week is just one particular atom and what does that look like. All right, so and what we're going to do too is as we go through all these things, you're going to see a bunch of like little drawings and stuff. I do want you to draw these because I think it's going to be very, very important. There's a lot of vocabulary words this week that are going to be somewhat confusing because they sound very, very similar to one another. But when you draw the picture that goes along with it, I think it's going to make more sense. All right, so there's actually there's really 3 different things that make up an atom. Now, technically, there's a bunch more little things that they found later on. I'm really not going to go into beta particles. Maybe you might go over it in high school. I'm not sure. We really, really barely talked about it even in college. So it all just depends on your teacher. But there's 3 main components to an atom that we're going to go over. All right. Number 1 is the nucleus. This is just a location. All right. And the nucleus is just the center. You probably learned something about the nucleus last year when you're talking about cells. Just like cells, atoms have a nucleus. And inside that nucleus, you have 2 things. You have these protons and you have these neutrons. All right, and I'm going to underline, I don't want to do this, but basically protons are positively charged items. All right, and the neutrons have no charge, or they have a neutral charge. All right, so the protons are positively charged located inside the nucleus. Neutrons are neutrally charged and located inside the nucleus. And a lot of times what you're going to see is they're going to be depicted by circles or spheres. And if you remember from our space unit, they are indeed spherical because of gravity. Gravity, remember we talked about if gravity makes things into a ball or a sphere, that's the reason why our planets are a sphere. So there is gravity that's inside the atom, and those make up a sphere. And so a proton is kind of like a ball, a neutron is a ball. And our last thing that we're going to talk about is the electron. All right? Electrons are outside of the nucleus, and these things are negatively charged. All right? The hardest part of remembering this, because this might be the first time, clearly I've done this so many times, I know that protons are positive. The way I remembered it when I was learning it is protons starts with the letter P, right? So it starts with the letter P, positive. Protons, positive. P, P, P. Think of P, 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 P. All right? How do I remember neutrons? I just think of the word, how does neutron start? It starts as N-E-U-T-R, neutrons, neutral. All right. So, and then the last thing is electrons. I just think it's negative because that's the only thing that's left after something is positive and negative. So protons are positive, neutrons are negative, neutrons are no charge, and electrons are negatively charged stuff. And these electrons are outside the nucleus that kind of just roam outside. It's a little bit more difficult to kind of explain, but if you think about how our planet goes around the sun, it's very similar how electrons move around like that. They do kind of orbit. They do have a little bit different pattern because they can change their orbit of how far they go from the nucleus. We're really not going to talk too much about that, but just get the idea that the electron is outside the nucleus and it's going around the protons and the neutrons. Okay, so that's the basic structure of an atom. All right, so a little bit more about the atom. So we can find a couple more things about the atom, and that's the atomic number. The atomic number, and we'll practice this too next week as well when we talk about the periodic table, but the atomic number gives the atom its identity. In other words, it's its number of protons right here. Right? I'm going to underline this as well because I want to make sure that we're not just highlighting things, but we're also underlining stuff as well. All right. So when I say the number of protons, if I count, so in this case right here, if I draw this picture, again, I want you to draw this picture and so on, that you'll see that the protons are in blue. All right. You got 1, 2, and 3. So I have 3 protons in this atom. That means my atomic number is 3. All right. The other thing that we can get out of the structure of the atom once we draw it correctly is you can find its mass number. Oops. And the mass number is just the number of protons plus the number of neutrons. So really what it means is everything that's inside the nucleus. So I'm going to write that down. So everything inside the nucleus. All right, so if I counted all the stuff inside the nucleus, so for example, in this one right here, right? And I know this is boron. If I count, I got 1, 2, 3, 4, 5, and 6. So I know that my mass number is 6, all right, because I have 6 things inside the neutron, all right? And then the last thing is if I draw an atom correctly, I should draw it where the number of electrons equals the number of protons, which means an atom by itself is neutrally charged. How do I get that? It's because neutral just means that the number of positive things equals the number of negative things. So if I'm thinking about math, I get a 0, right? So in this case, if I have 3 protons, that means I have 3 electrons. And based off of the screen that I saw before, that protons are positive and electrons are negative. So if I have 3 positive things and I have 3 negative things, those charges cancel each other out, so it's going to be neutral. All right. Now, is this always the case? No. All right. Well, when we start talking about chemical bonding, this is not going to be true. Number of electrons are not going to always equal the number of protons. But when we get to that, we'll explain why that happens. But as of right now, we're just talking about the atom by itself. When the atom's by itself, the number of protons equals the number of electrons. Okay? All right, moving forward. Now, let's build one together. So this is what you're going to kind of do this week as we go through. So here we have an atom, and I'm asking you to make an atom with 4 protons and a mass number of 8. So right away, we should recognize a few things, and I'm going to talk through it as we go. I want you to make this, so please make sure you're making it. All right, so number 1 is atoms with 4 protons. That's pretty easy, right? So my protons right here, they're the positively charged items. I know that they are in the nucleus, so I'm going to drag these to the center. So here's my second one. Here's my third one. And here's my fourth one. Okay? So I know that it has 4 protons. Right away, I should be able to also get another one very, very quickly. If I have 4 protons, and I know that my my atom has to be neutrally charged, I also need to know that I have to have 4 negative things. So I know I need to have 4 electrons. So I'm going to drag 4 electrons over here. Now, right now, you can see these little like yellow things right here. Oops, it's not working. All right. Interesting. Okay, so we'll just go like this. Make 3 more. Put these along here. You'll notice that I have 2 little rings right here. There's a reason why it's this way. I'm not going to go into details right now to say why didn't I just put all 4 into one ring, right? I could have. I'm just trying to show you that in reality, this is not the way you would actually draw it out. I'm trying to draw an actual right one, so that way when we do get to this in a couple of weeks, it'll make sense to you. Okay, but as of right now, if you made it and you drew it all onto one ring, that's fine. I just want to let you know that an atom with 4 protons will actually have 2 rings that these electrons are going to be going, and then you're going to have 2 sets of rings that electrons orbit. We'll talk about that a little bit later. But anyway, I have now 4 electrons, so 4 negative particles, and I have 4 positive. So I'm good there. The question becomes, how do I know how many neutrons I need to have in here? Well, there's one thing that tells me that information. My mass number of 8. All right? I learned from my last slide, if I go back to my last slide, that the mass number is the number of protons plus the number of neutrons. So if I look in here, I know that I have 4 protons. So the number of neutrons plus this equals 8. So I know that 4 protons, 4 plus 4 would make 8. So that tells me that I have to have 4 of these. So I'm going to come over here, grab 4. I'll make another one. 2, 3, and 4. There you go. All right. So now I have, if I count, I have 1, 2, 3, 4, 5, 6, 7, 8 items in my nucleus, which is correct with the mass number of 8. And that is how I would build an atom. Okay, this is the correct way to make a atom with 4 protons. All right, so hopefully you drew that out. This is the correct drawing. All right, so next thing that we need to talk about is this thing called isotopes. This is kind of a difficult part to visualize because you can't really see this part. But isotopes are atoms with the same number of protons but the different number of neutrons. Basically what I'm trying to say is this. If you kind of think about isotopes, not every atom is the same in the sense of not every carbon atom is exactly the same, right? Not every hydrogen atom is exactly the same. It doesn't have the exact same atomic structure. The only way that I can kind of describe that is chocolate. There's different types of chocolate, but they're still all called chocolate. Like, for example, there's milk chocolate, there's white chocolate, there's dark chocolate, there's Hershey chocolate, whatever the case is. There's different types of chocolate. They kind of all look different, right? But ultimately, they're still called chocolates because they have certain things that make them into it, that make them a chocolate. The same thing with atoms, right? If I have helium, there are a few types of helium out there, or whatever. They can be different in one way: the number of neutrons. All right, they're going to still have the same number of protons, but they might differ in number of neutrons. And when you change the number of neutrons, it makes them heavier. It will change their chemical properties, which means that it will act differently. Sometimes it will become deadly if it wasn't deadly before, and those types of things. All right, and the way you can identify an isotope is by its mass number. All right, so for example, let's look at helium. All right, there's 2 different types of helium: helium-4 and there's helium-3. Now, the one that we know that we put into balloons and stuff is helium-4. This is the one. Now, the other thing I want to mention is this. You're going to see this written a lot. where you have the name of the atom, and then you're going to have a number. That number is its mass number. All right, that's how you would know how many protons and neutrons are inside here. So if you look where it says helium-4, there's 1, 2, 3, 4. And then over here, there's helium-3, 1, 2, 3. So that's the name of the actual helium. So these are what's called two different types of isotopes of helium. All right, because one helium has two neutrons. I'm sorry, yeah, two neutrons, the green ones, and one has one neutron. All right. Now you might think, well, what's the big deal about having just changing that one neutron? It's a really, really big deal. All right. Helium-4 compared to helium-3 is very, very different. All right. The helium-4 that we have right here, this is the one we put in balloons, and when we suck it, we get our, and you try to talk, you get this, little whiny voice or whatever, like little cartoon voice. Well, helium-3, you wouldn't want to do that. All right. It's actually a radioactive atom. So you don't want to look at that. We really don't get helium-3 a lot, so we don't really have to worry about it. But these are what we call isotopes of these atoms. And structurally, they're very, very similar. They still have the same number of electrons. So if you look, both of them have 2. Both of them have 2 protons. The only difference is that they have different number of neutrons. And that is a big deal. And you'll see in the video when you watch it what an extra neutron or having one extra neutron or one less neutron can do to an atom. Okay? So let's now talk about what that would look like. So for example, let's say that I wanted to make boron 10 and boron 11. All right? So I'm going to go over here and I'm going to make my atoms again. All right? So in each case, I should be able to know that boron, so I know that boron has 5 protons. So I'm going to just drag these over here. All right, 2, 3, 4, 5. And I'm going to make 5 here. 2, 3, 4, and 5. And I know that it's also going to have 5 over here as well. So I'm going to move these over here. All right, and again, as I'm making these, you should also be drawing these as well. Okay, don't just watch. You might have to pause it a little bit to keep up, but I would do that. All right. The next thing I know is this: if I have 5 protons, I also have to have the same number of electrons. So I'm going to make 5 of these. And I don't know why that's not working, but all right. Anyway, I am going to come over here. I'm going to put my 5 electrons over here. Like this. Again, don't worry about the whole why are there 2 rings. I have no idea when you should have more than this. Why do you only put 2? We'll go over it. If you really want to know, it's actually, the answer is on the periodic table. Okay. But anyway, let's go over here and make 5 more over here. And again, after we do this, what you should be thinking about is, how many neutrons now should I have? All right, and how do I figure that out? Well, just like last time when I figured this out, I should be looking at this number right here. Again, remember, this is my mass number. And if you remember, if you go back to your notes, the mass number is the number of protons plus the number of neutrons. All right, so if I have 5 protons and my mass number is 10, I know that I should have 5 of these. Right, so now I'm going to put these into my nucleus. Right, because neutrons go into the nucleus. Oh no, this thing is working. That's weird. Okay. 2, 3. Oh, I'm sorry, 1, 2, 3, 4, 5. All right, now, the difference now between boron 10 and boron 11 is, again, if I look right here, this is my mass number, right? So this time, my mass number changed, which means the number of things inside my nucleus should be different. But this time, I still only have 5 protons. So in order to get to the number 11, I have to have 6 neutrons, because 5 plus 6 equals 11. So I'm going to come over here, and this time I'm now going to have 6 of these things right here. Let's get rid of these guys. Okay. All right. So the difference between this isotope of boron and this isotope of boron is that I have 5 neutrons and I have 6 neutrons over here. Again, might not be, it doesn't sound like it's a big deal, but it actually is a very big deal when even just that one extra little neutron, even though it's a neutrally charged item, it does affect what that boron looks and acts like. Okay, so but again, it's still boron because both of them have 5 protons. All right, so that's how you would build an isotope. All right, last thing that we're going to talk about is how atoms combine and what they're called. Last week we talked about, or 2 weeks ago, we talked about compounds already. All right, so you kind of have a good idea what compound is. It's when 2 elements or more combine together. Okay, so it's the same thing, but this time the difference that you have to know is that it has to be different types of atoms chemically combining. All right, so in this case we have sodium, so this is sodium, and chlorine make table salt. All right, now the thing that we talked about is this: compounds. When you create a compounds, the final compound is going to be drastically different than what they were to begin with. For example, sodium is very deadly. All right, chlorine is also very deadly. All right. However, when you can make them into a compound, so in other words, you combine these 2 atoms together, you can create something that tastes good. All right. A lot of you guys like salt. You put salt on fries. You put salt on a lot of things. So you can take 2 deadly things and make a good thing. Vice versa. You can take 2 very good things and make something very bad. All right? So that's what happens when you create a compound. And the reason why it's different is because they're chemically combining. When you chemically combine, you're creating another pure substance. And that pure substance is going to act, it's going to look very different from its individual parts. All right? So that's that. Now, the big key word, because we're going to talk about molecules next, is they're different types. This is huge, right? Huge. Different types of atoms, right? So sodium is one type, chlorine is a different type. Okay. Now, molecules, on the other hand, are when it's a very general statement. Molecules are when 2 or more atoms chemically combine. So in other words, this time, molecules can be created from the same type of atoms or from 2 different ones, just like a molecule, right? So in other words, if I wanted to really say this, and this is probably going to confuse some of you guys, all compounds are molecules, but not all molecules are compounds. I'm sure I just threw some of you guys for a loop right there, okay? But but yes, all compounds are molecules. So if something is a compound, it's also a molecule. But if you say it's a molecule, it's not technically also a compound as well. And the reason why is, let's say, oxygen. Oxygen that you breathe is actually O2. So if I wanted to write this out, it would be O2, right? And this would be H2O that you see right here. This is water. This is oxygen. This is a molecule because it's 2 of the same atoms combining. A compound is not like that. A compound is where you have 2 different atoms combining. Okay, that's the difference between a molecule and compound. It's really not that different. It's still atoms combining together. It's just kind of a technical thing where it's only a molecule, or it's only a compound when you have 2 different ones. But if it's the same, it's a molecule. Okay? And again, same thing over here. Molecules also, just like compounds, are very different when you combine them together than when they started. Okay. All right, last one. And here's some more examples before we get to the last thing. Okay, as you can see, these are more examples of molecules. So if I wanted to go down the list too and say which ones are also compounds, right? The first four that are up here are just molecules. Why? Because it's two of the same atoms combining together. Now the bottom four are molecules and compounds. Why? Because you have two different ones combining together. You don't have two O's combining together. You don't have two N's combining. Each one is combining to a different atom. And that's what makes it also a compound. But any atoms that combine together are called molecules. So anything, if you have more than one atom combined together, they're all called molecules. Compounds are just specific types of molecules. Okay? All right, last thing is how do we write a chemical formula? All right, so in other words, how do I do this? This is what's called a chemical formula, O2, H2O. I know that we call this oxygen, we call this water. But in chemistry, we like to shorthand stuff. All right, so instead of saying water, we call it H2O. All right, so how do we write this? All right, so if I know what atoms are combining, whoops, all right, I can, that's not good. Okay, I can say how to write it. Okay, so in this case, I'm going to do the first one. I want you to do the last two on your own. Okay, so let's say it says one atom and you have two atoms of hydrogen. Okay, so what I do is I would write H first. Now, you might not know the difference between which one goes first. It's just obviously, I will get into that a little bit later. But I know that H equals, and it says two atoms. So the way I write that there's two atoms is I would put H and then I would subscript the 2. This 2 right here tells me that there's 2 hydrogen atoms. And that's combining with 1 oxygen atom. So H2O. There you go. Now some of you guys might end up writing it like this. You might go OH2. Okay? Which isn't which isn't wrong, but we just don't write it that way. And there's a specific reason why we don't go OH2 instead of H2O. All right? But you probably may make that mistake. You might make that mistake here. All right? You might not know the exact chemical formula for that. But this is the proper way to write H2O. Okay? It's not OH2. All right, now the next thing is this compound, molecule, or both? I hope everybody's saying both, right? The reason why is because it's a molecule, because it's molecule all the time whenever atoms combine. But why is it also a compound? It's a compound because you have 2 different atoms combining together. Okay? All right, so I want you to do these 2 on your own. Okay, so pause it. All right, hopefully you've paused it and you wrote it down. If you wrote this, you are correct. Okay, this should just be a molecule and this should be both. Okay, now hopefully you got that this was just a molecule. It's not going to be a compound because you only have one type of atom combining. Okay, all right, and then here is your summary. Please do that. So pause it, write it out, and then last thing I want you to do is there are 6 videos that are on my website. I want you to watch it. It should give you a little bit better understanding of atoms and so on. Right, and that is the notes for this week. I know it's a little long, but that's the notes. Thank you.